Good morning, everyone. Good afternoon. Sorry, good afternoon. Yeah. Sorry, may I know who is convening this thing? Is it Akshat who is mediating this? Hello? Yeah, yeah. Okay. Yeah, I can hear you. Yeah, yeah, sure, sure. I'll just start my video in that case. Just give me a moment, okay? I'll just start the video. Hello? Am I visible now? Yeah, okay. Yeah, yeah, sure. Uh, yeah, can you maximize the screen? Or if you want, I can also do the same. I'll take over, Akshat. I think it's fine. That was just for backup. So maybe I'll just take over and I'll start presenting the slide. Okay. It will be easier for me. Yeah, yeah, sure, sure. Go ahead, please. Yeah. Yeah, thanks for the nice words. Uh, I hope you guys will like the presentation. Uh, yeah, thanks Khatri sir for giving me this opportunity to present it here, and the ever enthusiastic crowd of SGSITS, especially instrumentation department. So we'll get started off with a little bit introduction. You have already given the introduction, but maybe I'll just add a few things so that you guys can more align with what I am trying to do and what I had been. I was at one point of time just a student like you, in the instrumentation department. I did my engineering from there, right? So lots of memories related with SGSITS, and with the faculty and with the friends and colleagues that we have worked over there. Even we used to interact with the MTech guys. Right, the VLSI lab had just started when we were there, and it was the 50th year anniversary. So we remember all those things, and we are very grateful that I'm very grateful that I got an opportunity to study at such a prestigious college, which is kind of crown of Madhya Pradesh from an engineering college perspective. Very glad to be giving or sharing my experiences with you all. I know there is a lot of fire within SGSITS. People have big aspirations, going technically, GRE, MS, CAT, everything. I know, like, even in my batch, we had so many people who had reached so many places. And me personally, being very enthusiastic technical guy, I always wanted to be in the technical field, and I chose my career direction accordingly. And I hope I can help you guys choose and bring in some of the perspectives that are available in automotive technology that I have been through over the years. And I hope that that ignites a fire in you guys also, so that we can take the name of our college and take it to international level. So let's get started. uh, yeah, so Akshat, if you can maximize the screen, I think it will be a little bit more clearer, the PPT. Yeah. Yeah, sure. Just a second. Yeah. Uh, so yeah, you can go to the next one. Yeah. So to get started, right? I did my schooling from Indore itself, from SDSP Indore, and then I did um, my B in electronics and instrumentation. Studied from the year 2001 to 2005, and then I got selected for Infosys during the college campus days, and there I worked for almost 2 years, from 2005 to 7. But I always wanted to be in the technical field, and specifically I always wanted to be in India. So I chose some fields for which I could get job opportunities back in India. So I studied, I did my master's in signal processing from Missouri University of Science and Technology. It was then called University of Missouri, from 2007 to 2009. in the field of signal processing. And yeah, then I worked in Garmin, which was kind of world's first navigation company to say as such, right? It was I think around 1989 they were founded. And whatever we see today in the form of phones, kind of these guys had the same technology, like touch screens or tablet kind of things, which the only difference was it was used for navigation. Like you can the earlier versions, people used to go by maps, but then Garmin was one of the companies that innovated touch based devices, the resistive touch based devices. And they had all the maps loaded, and they where you could use it for navigating. So that was one of the core companies to enable the navigation through voice commands, even before Google Maps was there to say, actually. I mean, even in like the year 2005 2007, they were working with voice technologies. This was Kansas City in the US. So after that, I decided to move back to India, as was always my plan. And here also I've been working for the past 12 years almost now. And I'm working in similar technology where we enable all the cars that we see, right? All the car commands for through voice commands. Probably guys might have seen many ads, like I don't know, specifically I personally have worked on a few that have gone for Ford, and Chrysler and Subaru, and even Tata, that you see, right? All the Tata last generation for the past 10 years, all the voice commands and stuff, we had been working on through Harman to provide those. So that is some of the commands. Recently, we had integrated Alexa as a part of the automotive domain, and you can see some of those features in the latest Tata cars, especially the EV ones. I think that's where they have officially launched them. Yeah. So let's move on to the next slide. Yeah. So these are roughly what I'm going to speak about the automotive cockpit, what it is about, players in the field, different components, and that will be kind of brief that I'm going to tell you about those. But majority of the part is going to be about what is there for engineers as such that we can explore going around in the future. What all technologies we can work on, what all components or sub components can work on. So that is the bulk part of my presentation. And I definitely know that there are a lot of curious students here, and we have a lot of questions. So I wanted to reserve explicitly 30 minutes for answering all the questions. I think Akshat will be helping us jot down all the questions. I will avoid taking verbal questions directly. Maybe you can give those to Akshat in return, and he can compile, so that by end of like around 1.5 hours, around 3:30, we'll try to address all those questions together, so that I can answer more efficiently. Um, and yeah, maybe we'll go in two sessions. We'll just go for 40 minutes and take a 5-minute break, and then continue the second part. During that break of 5 minutes, you can hand over your questions to Akshat, and you can keep collecting, so that it's all your questions are answered. Right. Sure, sure. Yeah, that will be great. Yeah, thanks, Akshat. Yeah, sure. Yeah. So yeah, we can move on to the next slide now. Yeah. So what is automotive cockpit? So just you guys might be aware, right? There is a cockpit in the aeroplanes, right? So just like aeroplane is a very complex machine, which you'll have to see what engine is on, what RPM it is running, what temperature it is, right? So now that cockpit term used to be used for aeroplanes and flights because they were very complex in nature. But really to say, cars nowadays are no way behind. Okay. Can anyone guess the number of ECUs that we see in a normal day to day car? with latest technology? Any guesses from anyone? How many electronic control units do you think a modern car might have? You can raise hands and answer if you want to. Any guess? 220, 200, 2000? That's still on the lesser side. Uh, so so modern cars have around 200 ECUs right now, that chipsets that will be uh, you know um, that will be used to kind of coordinate all the functions that are going on in the car. And when we say about cockpit, so there are lots of display systems, the basic things, like you can see RPM, you might have seen in the cars, right? The dials, the temperature, the engine oil, that used to be the conventional one. Now came the next generation, where you can play the radio through touch screen, right? You can tune to FM, you can plug in USB, you can connect your phones, make calls using that, use Google Maps, all those things. So all that touch screen that you see, right, to which you pair all these devices, that is called as the head unit, or we also call it as IVI. So that is the one that you can interact with most of the time through touch panel. Now conventional cars had like smaller ones, right? Maybe what we call as 1 DIN or 2 DIN, and they were only like LCD based, or you can just touch through some buttons, the old radios. But the modern ones, if you see, right, if you see one of the Teslas or Mercedes, the whole dashboard is kind of a virtual screen, so they've got like 18 or 20 inch, or sometimes even 30-inch displays, right? So now the trend is towards one integrated display, where you can see everything. You can do navigation, you can play music, you can make phone calls, and you can see the RPM of the car. If you're low on fuel, everything will be displayed in one single screen. That is what we call nowadays as the automotive cockpit, which is applicable for all the cars that are modern cars that are coming in. So that is where we are going to go ahead and see what are the opportunities available for them. And the common operating systems that we use, traditionally it used to be QNX systems, which were very safe and real time operating systems. We still use those for the critical functionalities, like cluster displays, which tell you the RPM and fuel and the real time data. But since the age of cell phones, right, everyone wants to be used to be able to touch what they were seeing in real time, and they want high level of graphics, and you want to be able to see rich graphics and see real time responses, right? So for all that, now going forward, it moved from QNX to Linux to Android systems. You'll be surprised that it's an automotive variant of the Android version. It's not the exact same one as the ones that we use on phones, but the core modules are like 90 to 95% all the same, and automotive features are built on the top of those. So these are like, so you can have a look and feel of the Android systems, but still you can cater those in the cars. And plus with Android, like, as you have all these features, right, connectivity with cloud and all Android functionalities that you can think of, you can browse the apps and install, go to Play Store, install music, all those things are available. You can do all those things on your car now. You don't have to be reliant on your phone alone. Obviously it will be tied with your phone, because you need real time connectivity with data. For that, you need to connect with a phone, or any source of Wi-Fi data that you can use through your phone tethering. But that's how it is. Yeah, so we can move on. Next slide, please. Going to who are all the, yeah, you can go back one step. Yeah, who are the OEMs, right? So when we say OEMs, it means original equipment manufacturers. So who are these, right? So these are all the car manufacturers. It could be Mazda, Renault, Subaru, and Ferrari, and anyone and everyone you can think of, Jaguar, Land Rover, all these ones, right? So these are the original equipment manufacturers. But since their core expertise is making the vehicle go from point to A to B, right? And they want to focus more on the I should say mechanical part of it, or the physical components, like how is the seating, how is the dashboard, how's the cooling system. So these are their core technologies, right? So they have been doing it for years and they want to focus on that, right? So what they do is they outsource their main radio system, or what we call as the head unit, right? They outsource because it has a lot of software components, and for a car manufacturer, software engineering might not be their core expertise. Their more expertise will be like, how can I increase the fuel efficiency, right? They don't want to focus much on how does XYZ icon look on the screen when the user is using it, right? So they usually take the radio, what we call as radio, from a third party, right? So if you can move to the next slide. So these are called as yeah, so these are the tier 1 suppliers, what we call. Okay, tier 1 supplier means the company who provides that physically looking screen, or the radio, as we call it, the head unit that is attached to the car. However, the companies will make sure that if you touch and say, if you increase the fan speed, it is connected through the CAN, and it actually increases the fan speed, right? So that interfacing, those kind of things, there'll be interfaces and pre-decided signal mapping that uh, the tier 1 suppliers will do. So some of the players in this field are Harman, which I am working for. Then there is Vistion, there is Denso, Bosch is there, and then Panasonic is there, then Dese, and you know Alpine. So many are there, but uh, there are few key players who have been there for years, whom I'm trying to present. This is just to let you know, guys, right? These are the, I mean, I never had even heard about even single of these except Bosch, I'll say. Because when we go to get something fixed in our bike or car, maybe we'll buy some Bosch components, but we never know, right, who is supplying the electronic head unit, right? So these are the competitors. This is just for your knowledge, when you are searching for jobs, or when you are just browsing around, if you see something around these companies, please try to go and read what these guys are doing, what can I do which aligns with these things, right? So these are just a few names. You can just search for tier 1 suppliers for automotive in Google also, and get to be aware of who are the players in the field. Next slide, please. Yeah, so what are the key things, right? Cluster display, as I already told you, which shows the RPM, right? It's a very 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 basic display. RPM it shows. Sometimes it shows our fuel level gauge and all those things. Then domain controller, the main thing I told you about, which has the main display, the touch screen, that is called as the head unit. Then in modern cars, there is also rear seat entertainment. When you're sitting in the back seat, there are something attached to the back of the front seat, right, where you can touch and play. uh, this is an evolving concept. Many American and European cars have these, but now it is coming, this concept is coming to India also. And then heads up display. Now heads up display is like, there'll be something, there'll be a projector which will project. Let's say you're navigating, right? So I don't want to see at the head unit, right? So I'm driving, and the head unit is probably on the left side in the center of the car, right? I don't want to take my eyes off the road. So what this heads up display does is, it gets the inputs from the Google Maps, and it projects on my front windscreen, right? It will only show arrow symbols like turn right after 400 meters. So only basic stuff, so that I don't get distracted, right? And I'll be able to see it on the head unit, on my front screen, and I don't need to look at the screen as such. So that is what is called as the heads up display. This is very nascent technology, and it's still in progress, but something we should know about. Okay, we can move on next. Coming on to what is the most interesting part that you guys can go forward, can look up to in forward working in the coming years, right? So these are just a list: user machine interface, acoustic tuning. I'm just listing it out here. Tuner technologies, voice recognition, projection, ADAS, digital twin. We'll go to all these things in the upcoming slides. So let's go to the next one, Akshat. Yeah. So we'll start off with these. So basically, these are the 12 ones that I wanted to focus, right? Give 5 minutes to each slide so that you guys know like what this is something that I can associate with, or this is what I like. So I didn't want to go narrow on like 3 or 4 technologies, but since you guys are still learning and still going through courses while you're doing your projects, you can choose what, let's say if you're doing some internal projects, you can decide like, okay, I want to align with one of these topics which might be interesting to me, and maybe I can choose something which aligns with this thing so that it you know um aligns with your long term career goals as well. So user interface, right? So everything that we need to interact with on the touch panel, it should have something that I can touch, right? Just like on phones you have icons, and there is display stuff, and there are buttons and radio buttons. So all that comes under user interface, how the user will be interacting the with the car system, right? So that is the UX design. So there are a lot of tools that are used, because you have to standardize these things, right? It cannot be too big or too small, or too much bright. So there are a lot of standards for this which we need to use. Then animations. So for example, you might have seen when you speak on Google phone, right? There is that animation comes, that bubble thing and all. So it gives the user the impression that they're interacting. So like that, there has to be an animation. If you're switching to FM screen, it should show you the frequency. It should show you the slider if you want to scroll through. So all these are the HMI components. Then this is about the touchscreen part, but physically if you see, there are like knobs, like radio buttons, or there'll be slider in the car, right? If you want to increase the fan speed, or if you want to increase temperature, there'll be tab buttons. So all those things, right? Whatever physically exists in the car, even for that, there is a mechanical department which will design and make sure that it fits in the car, and the tolerances are very very narrow, right? They have to be very specific, otherwise this head unit which is built separately will not fit into it. What kind of plastics we need to use, if it has to be glossy and give a rich look, it needs to be chosen, and we need to build it with the right type of plastic. If there's a Ferrari car and it has to be red ambient color which aligns with their theme of Ferrari, then it has to be red in color. So things like these, if it is a BMW and they have one color theme, we have to stick to all those things, because that is the branding part of it, right? So we have to choose all those things carefully. And the physical parts, CAD and CAM tools will be used to design, right? So as a part of automotive, there'll be a mechanical division, there will be a hardware division, there will be a software division. There will be a division for physically the metallic parts, whatever built, right? So all those things will come into picture while building what we call as the radio, right? It has to comply to heating and cooling standards. Let's say if I go to Ladakh, and where the temperature is sub-zero, my head unit does not have to freeze, right? It has to withhold that temperature. It has to sustain that temperature. Or if I'm driving in a very hot weather, and it is 45 46 degrees outside, and the head unit is getting heated, it should not burn the components, right? So all these things should work accordingly. So that's where we need to decide all these things. Next slide, please. Yeah, now coming on to acoustic tuning, I think this is a very interesting part, right? So I mean, there are cars and there are lots of systems that speaker systems that you can have. one of the latest ones that we are working on, it has up to like 20 speaker systems in the car, that for an upcoming electric vehicle. And to be able to do that, we need to look at the car, like whether it's an SUV, how much is the space in that car, which speaker should be placed where to get the best impact, where should I put the subwoofer. In some cars, to say really, which we have worked on, we never had subwoofers because it takes a lot of space and there were space constraints, but we were able to create the same effect using the placement of the speakers. And that way the overall effect of the music system was very rich, and it helped us save costs and at the same time save space for the user to be used for otherwise storing luggage, etc. So there are a lot of tuner software, lots of softwares that we use for tuning. And you might have seen in some cars you can kind of just like the frequency bands, you can select like whether you want high bass, high boost, or if you want high frequency outputs or mid range, treble, everything you can control, right? So whatever you're touching on the screen and selecting, right, it should effectively give that effect to the user who is actually listening to all those things, right? So that is what we do as a part of acoustic tuning. So if I'm sitting at the driver, whether I'm sitting at the passenger, on the back left, back right, all those things we have to tune and make sure that every person is able to hear the perfect music. And it needs a lot of effort, lot of echo cancellations, DSP algorithms to be implemented. So that is it's a fun part, and you dedicatedly get acoustics lab for the same, right? So there are acoustic labs where we where it's a zero sound from outside. They are acoustically treated walls, so that there are no reflections of sound, and there's no external noise, zero external noise, right? So these are kind of some of the labs that we get to work on while doing all these things. And now going in the future, there is zone specific audio. So these are based on, obviously what we read as a part of the signal processing algorithms, right, as a part of digital signal processing. So every person will have specific zone audio, right? So from the head unit, the driver is listening to a completely different music, and there's a sphere of sound that he's able to hear. And the passenger, whatever they have paired their phones and whatever they are hearing, they are able to hear a completely separate sound with completely different audio settings, and it's a personalized audio, right? So those are kind of things that are done as a part of the acoustic tuning and zone defining. At the same time, uh, if I'm driving and I'm seeing a voice command like, can you take me to nearest coffee shop, right? So the navigation is going on. For me, it is relevant that it is giving me directions, but the co-passenger, they may want to listen to a completely different song, and they don't want to even listen to the navigation prompts at all, right? So they can tune into that zone, customize their songs and just hear those out. So these are the kind of things that are done as a part of the acoustic tuning and echo cancellation that we do as a part of automotive. Yeah, next slide please. Yeah, audio DSP. So this is another, to a normal user, as students, when we are not very clear on how it is different, it seemed like it is exactly what the previous slide was. But uh, from an implementation perspective, it has to be different, right? When I'm capturing the mic, there has to be a DSP, there has to be an analog device which captures the audio signals, right? We read about it all the time, the piezoelectric material, right, as a part of sensors, right? So that senses and then it converts it to a signal, and then we do an A to D converter, and then that sound comes in. So in a car, the minimum that you can have is one microphone, right? But it is not necessary, right? To cancel out the echo, we can have multiple mics. The more mics you have, the clearer the audio will be captured. So that is called as microphone array, right? You can have multiple placements of mics. You can have it on the central mirror, you can have one on the rider side, you can have one on the passenger side, there can be two on the back side, right? So all these things, and one of the things is, if I'm speaking command, if it's a diesel engine, it's very noisy. If you are in the traffic, there is surround noise. So we have to cancel out all those vibrations, right? Low frequency vibrations. So we have to write algorithms to remove those. Echo cancellation during Bluetooth calls, right? If you might have heard, right? Bluetooth calls, if you make a call, there's a lot of background noise, right? So if I'm as a driver, I am on a Bluetooth call through the head unit, and if the passenger is saying something, it should not go into whatever is being fed to the other side. So I have to cancel out the audio coming from other direction, right? So that is the directionality we need to use and cancel out other unintended audio. Now multiple zones. So this is about car. When I'm when as a driver I am doing this in one of the cool projects actually that we did for actually Harley Davidson is one of our customers. So there I mean, we cannot have officially mics, right? I mean, as a part of the, I mean, where will you put the mic on a bike, right? You're riding at high speeds and there's so much wind noise and background. So there what we do is, there is a touch screen. You pair your Bluetooth devices uh, to your helmets. So a helmet has inbuilt Bluetooth headsets, right? So it will pair your phone and your headset. Similarly, the co-passenger will also have a Bluetooth headset, right? So they both can pair, and they can speak the commands in uh, on their Bluetooth headsets, right? So this is so for example, just a simple use case, right? So the rider wants to be able to navigate to somewhere, right? So the driver can say, okay, take me to the nearest petrol station, and he will start hearing, right? So the directions are relevant only to that person, right? Now as a co-passenger who is sitting at the back, I just want to chill and relax and listen to some songs, right? So that is called as zone specific. Right here there is no physical interference, but I can pair independently, right? I should be able to hear phones from my phone as a passenger, and I shouldn't be caring about whatever the driving directions. So those kind of things, that is possible, and it has been going on for some time, and there are actually things like that we are going and doing stuff like that. Okay, and yeah, so this is regarding the audio capture and zone specific audio. Now coming on to the just the opposite side, the electric cars and two-wheelers are, they're so silent nowadays. It will pass behind you and you'll not come to know whether it has passed or and it has led to, it leads to a lot of accidents. Electric cars have been there in other developed countries for years, and there it's a real problem, right? I mean, if a pedestrian is crossing and they are not able to hear the car noise, it's dangerous for them, right? So now they are going for the next level, where inside the car it will be silent, just like an electric car. No engine noise, nothing. But for external people, so they will simulate sounds which gives them the impression that car is coming. So there'll be one kept at the front and one at the back, and it will depend on the speed of the car. It will be proportional to the speed of the car, right? So the nearby people, they are aware, and it will not lead to any accidents because they have not heard the car coming. EVD, so emergency vehicle detection. Now just think of it, you are driving your car and you're in a good mood, just listening to music at high pitch inside your car with your windows rolled up, no external noise coming to you. Now what if an emergency vehicle like ambulance or fire brigade is passing by? You'll never be able to hear it, right? And that's a risk, right? Because it's a risk to others, right? Because the vehicles will not be able to reach, because you are not able to give them the space to move around in the right time. So now there are algorithms where not only will put the mics inside the car, will put microphones outside the car in all directions, on the back maybe two of them, and in the front two of them, right? So that when the mic listens to predefined audio of all these emergency vehicles, it could be a police sirens, it could be an emergency vehicle, it could be a fire alarm, all these kinds of sounds, they will actually decipher it and play it in a proportional sound level to the user that tells them how close that vehicle is. So if the vehicle is far away, it will be a very feeble sound. But as the vehicle keeps coming closer and closer, inside the car, the volume of the emergency vehicle that it is playing as an alert to the driver will keep on getting louder and louder, and it will suppress the music level to let the user know that the emergency vehicle is approaching them. And going on to one more level, right? So I mean, modern cars, they have all these I mean, if you have Android phone, you can plug it in as an Android Auto device, and use it as a projection for mapping. Then you can also have so we call all these as virtual personal assistants, right? VPAs, or personal assistants, voice assistants, that what we call them. But let's say Google, right? So they may have trained all their data over the years for a certain different audio level. Alexa, they might have trained their server to detect audio at a certain level. CarPlay, I mean Apple, they might have trained all their map data. But at the end of the day, right, they all need clean data, right? So when they are letting us use, we have to certify that our car is Google certified, is Alexa Amazon certified, or Apple certified. These guys give us certification, but they tell us that you have to feed me the audio at this particular dB level. If you don't give me the dB level, then you cannot use my device, and you cannot claim that this product is integrated in your car. So I have to do it differently for each of the devices separately, and I have to do that customization. So even though at a smaller level that may look like a very trivial job, but you need to know the acoustic level, right? How much dB I need to suppress for this supplier, and you have to customize it. People can switch between these, right? One of the friends has Google phone, right? Another one can have CarPlay. So if they plug in and switch the device, it should completely change the audio in the background that is capturing, how it is sending, how it is filtering, all those filters that are applicable, what band pass, and all the suppression of car vibrations, that has to be completely switched in the background based on whatever phone is plugged in, right? So that is that is one of the jobs that we have to do as a part of the audio integration for a particular car, and this has to be done for every vehicle that we make. Like every car has different internal acoustics, and the car inside may change. Someone will put a plush leather seat, someone will put a rug, or someone will put a pillow, or someone will be someone will be driving very close to the steering wheel, someone will be backwards, and we have to accommodate all those challenges as a part of this, because these are very normal things. As a user, you can do anything you want, but I have to be able to accommodate all those things as a part of the car environment. So that is the challenge that we see on the audio front. Yeah, we can go to the next one. Yeah, tuner technologies. So AM FM is pretty much basic, right, which we all are aware of. Now there are additional things, right? So this is mostly for different countries, different geographies, everyone is different, right? So in India we mostly used to AM and FM, but in Europe there's something called as digital audio broadcasting. Okay, so there they are not transmitting regularly as a regular FM band, but they digitize it, and they want to give a richer user experience. They'll compress the audio through different algorithms. I think MP3, MP4, some different algorithms they use, but it is to compress. It is unconventional, just like regular analog signals. They are compressed, actually. It is compressed and decompressed at the they are from the tower or wherever they're broadcasting. They'll compress it in some format, send a frame, it will get decompressed at the driver side, and it will play all those things. So that is the digital audio broadcasting, and it is very famous in Europe, where and in a lot of countries where they want to listen to all these things. And then there is Sirius XM. So this is more specific to North America, where it is transmitted through satellite radio. So in the normal tuner, right, you might have seen FM towers, right, all those things that are transmitted. But this is something that so let's say if I am in Indore, right, and I say Radio Mirchi, then it will be a different frequency. In Pune, it will be a different frequency. In Bangalore, it will be a different frequency. So I have to keep switching to that one, and it will be a local audio broadcast, right, which is specific to that city. But this satellite radio, this is common wherever you go across the globe. If you have a favorite channel for Indian music, you can listen to that. If you want to listen to hip hop, it will be only at that frequency, and it will always 24/7 it will be playing that. You don't have to switch the frequency. It will be the same content. So it is called a Sirius XM radio. So they have different genres of music, different frequencies, different kinds of audios, right? All those things you can do. Okay, so those you can play all across the globe. So it's not only about this. So you have to tune in the hardware components also for this, right? Because there will be a receiver for each one of these frequency bands. For FM and AM, it is separate, and for DAB, it is a different chipset. So correspondingly, software you will also have to do. On display also, you have to do the same thing, right? You have to, there the channel names will be different. In digital audio broadcast, for example, right, if it is playing one song, it will tell you the artist name, the album from which is playing, what year it was. It will have some extra information about the song details and everything, which we don't get as a part of conventional FM radio or AM radio. Same thing goes for Sirius XM also. So there also will be able to get lot more stuff, and be able to like global music. You can hear music across the globe, but but you have to have a transceiver for that, which can receive all these uh, different frequencies and corresponding to different geographies. Yeah. Next slide, please. Yeah. So then there is voice personal assistant, like I said, and this is the one that I have been working for over years.
इवेंट में जाने के लिए इसलिए मना तो नहीं कर रहे थे कि कल को है ना तुम इवेंट में जाओगे 9 तारीख को, फिर तुम्हारी बंदी बोलेगी अच्छा मूवी नहीं जा रहा था। मैं पैसों के लिए कर रहा। अच्छा, मैं पैसों की टेंशन मत मारो फिर।
Hello. Am I audible? Yeah, sure, no problem. Okay. Yeah. So one of the key things, right? I mean, maybe many of you have used Google, right? So you can say, hey, okay, Google, set a timer alarm for 8 a.m. You can just say, Alexa, play the song XYZ, set up timer for 10 minutes, blah, 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 right? All those things. So those are called as the wake up words, actually, right? So this is a separate technology where we need to be listening to all these keywords. And obviously, like from a hardware perspective, if you think the CPU, the mic has to be open all the time. And let's say I'm already playing a song, right? The music is, I'm in the car, I'm playing a song, but I want to interrupt. Let's say I want to just hear two songs from Arijit, right? So I can say, hey Alexa, play songs from Arijit. So it should be able to cancel that ongoing music, right? On the top of that, it should be able to recognize what I am saying, right? So all those things, that is called as acoustic echo cancellation. So you have to feed in whatever it is playing back to the engine, so it cancels out that and whatever, and filter out the background noise. So when you speak, right, it definitely there'll be audio that you speak, plus if there is some external car noise, right? So I have to first cancel out the original playing audio, and from the external audio I have to filter out the car noise. Maybe if some other person is speaking in the background in the back seat of my car, it has to cancel that noise, and it should focus only and only on what I am speaking, right? So those kind of things are wake up word recognitions, right? So that is, and it has to keep listening. So your processor has to process all these things. It has to have RAM so that it keeps listening all this time. So it's obviously it's a from a system perspective also, a CPU can do so much stuff, right? It will have so many dmips or cycles that it can process so much RAM, right? So I have to balance out other applications, so that it can keep listening. Now there is automatic speech recognition, what we call as ASR. So there we can kind of the normal command, like I can say, hey car, open the sunroof, right? So hey car is wake up word, and then open the sunroof is actually the command, right? So I listen to that audio, I put it through a recognition engine, I get the data, then I interpret it, and when I know that okay, the user is trying to open the sunroof, then I map it to a CAN signal, and then send a CAN signal which maps similar to what you will do. Let's say if there is a physical button for open roof, right? If you press that, it should simulate the same signal, right? So I have to send that signal, and then it will send it to the CAN signal of the car, and then it will open the sunroof for me, right? So that is the automatic speech recognition part. Now it has to communicate back to you as well, right? So you cannot just, so if you say hey car, open the sunroof, then it should speak back, okay, opening the sunroof for you. So that is kind of text to speech. So based on whatever I recognized, if I am successful, I have to convert the text that I intend to play back to audio signal and play it back through the speakers, right? So that is text to speech. Now about these things, right? How do I decide what to speak, when to speak? Now let's say if if I say something, let's say I'm playing 94.3 FM frequency, right? And the user says, again, tune to 94.3, right? The system will check what is the currently playing frequency, then only change it, right? So in that case, the prompt has to speak, sorry, you are already on 94.3, right? So the response is different this time. If I was on 93 and I was switching to 94.3, then it will speak 94.3, tuning to 94.3, all this thing, and it is called as dialogue management. This is the trickiest part, which we need to customize for every vehicle, because every vehicle will have different sets. Maybe in a Ferrari, you want to act differently because they want a different user experience. That is where you can do all the customizations, and that is the bulk part of the I should say the user experience, which is different for every vehicle. Now going to system integration, right? As I said, right, how do I accomplish? If I say tell me how much petrol is left, so it has to go and check the fuel level service, right, which is a software service internally, and then it has to get the data from sensors and give it back to me. So I need to be able to publish as an intent. If I want to launch radio, if I say just play radio for me, then it should be able to do it, right? So all these things we call as intents. What is the intent of the user? Okay, then next is language support. So now you're thinking only one country, right? Let's say in India we use mostly Hindi, English, Bengali, Tamil. So these are the languages. But if you go globally, I need to be able to do it for every language in the world, right? Which is I mean, sometimes there is a master set of 20, 25 for most of the OEMs, but it is not restricted to those. Sometimes you have to go as many as 50. So I have to give the same user experience in every language, right? So even if you might think in Canada, which is North America, which is a country in North America, there is a French version which is called as Canadian French. And when you go to France in Europe, it is technically called as the French, the original French, right? So these two, even though they are similar, the accents are different, the vocabulary is different, and maybe 80 or 90% is the same, but we still have to customize it for that particular country. Okay, and let's say US English let's say US English versus uh, Australian English. They are two different accents, but we have to have different acoustic models to recognize the different TTS, like text to speech. The accents are completely different, but we have to customize it. That now going forward, the future trend is I should be able to recognize multi-language at the same time, right? You might have seen in Alexa, maybe, for example, right? You can say मेरे लिए कुछ song play करो, right? It is a mixed thing, English, what we call, right? So it is able to, it is a mixed language, or I can immediately switch, right? Maybe I'm driving in India, so it is assuming that I'm Indian, speaking in Indian English. Let's say if someone from Africa comes and they start speaking English, then they should be able to detect that it is African, South African English accent, and it should be able to support that, right? So that is, it obviously needs a lot more resources and data to be training used in training, but that is what we need, what is the challenge. And then natural language understanding. So historically, right, this is all driven by CPUs, right? So earlier we used to have very low power and low processing CPUs. So we used to have very fixed commands, right? So I'll give you a practical example. We used to have engines which we had only 20 MB RAM. That's it. That's all we need. That's all we have on the processor for voice recognition applications. So we used to have very smaller set of commands. We'll recognize only 20 commands, right? We'll just say radio, FM, AM, set fan to 20, set fan to 4. Very fixed. If you deviate here and there also, no, if I say please set command to 4, it will not work, right? Because it was not capable of processing those things. It was what we call as fixed command set or fixed grammar. Now the trend is towards, like, obviously with Google and all these things, the people are saying in normal way and any number of ways. Can you hit my music? Can you hit my favorites? Can you play my music? Please play music for me. Please play some songs from genre pop. Anything you can say. That is called as natural language understanding, and that is the challenge, and that is the thing that is coming as a part of the latest and greatest voice recognition engines that you see. Yeah, with that, we'll stop here for 5 minutes. I'll also quick water break, and you guys can collect questions. We'll convene back at 2:55. Okay, thank you guys. I'll be back in 5. Yeah, hi Akshat, I am back. Hello, can you guys hear me? Yeah, yeah. Okay, we'll continue then. Please move to the next slide. Yeah. So yeah, okay. So going along the list of other domains, so there is projection devices. Okay, so obviously it is based on if there are Android devices, you can always connect it as all the Android devices through Android Auto, which is kind of a pretty famous interface for projection devices. I'm not sure, maybe many of you, if you have used it, then you can use the Google Maps or Spotify, Groove Shark, whatever music you want to play, and you can pair phone calls, and it will pair with your phone for all the Android devices. So we have to comply with all those guidelines that they have, and what they are projecting. And similar for CarPlay. I mean, so these are kind of two competitors in the domain, right? Like Apple CarPlay will have their own standards, their own interfaces, their way of showing on mapping, their own coloring scheme, right? So when we are projecting this, we have to as a display, the display that we use, it has to stick to the thresholds, right? This should be the light intensity that should be coming out, this should be the contrast that you are seeing on the screen, and there should be no audio interference when we are doing this, when you are playing back the music, xyz level of music. So all those things we have to align with. And obviously in the background it pairs with your Bluetooth if you want to, and you can make all your phone calls and everything, and play all those devices. It also gets plugged in if iPhone is there, whatever you have in your iTunes, you can also listen to those music as a part of the projection device, and play those devices. Next slide, please. Yeah, so ADAS is also something that many companies are trying to do. So basically, this is about kind of sub part of autonomous driving, advanced driver assistance systems. So there are multiple levels in this, right? Like 1, 2, 3, 4, 5, and many companies in India are doing level 1, level 2. Like automate park assistance, RVC, like rear view camera. So there are different levels, right? 5 is the highest one, where it is completely being able to drive on its own, and trying to kind of play drive those things, but parking assist kind of thing, that comes to level 2. So for that you need to have different levels of I will say sensors integrated, right? So there have to be lidar sensors, and then there have to be cameras, multiple cameras installed. So all these data, right? And obviously you need a lot of processing power, right? So you need a graphic chip to process all these images that you're getting real time, and calculate, and first of all you have to also train the data, right? Like if I see something like this means it's a pedestrian crossing, so I cannot, I need to stop there. If there's a red signal, I need to stop there, right? So they have to train all this data, and they collect years for data, and try to train based on those. And at the same time, in real time processing, right, how to interpret that data, right? If I get this information, if say, there's an immediate crosser by, right, who is going, how do I interpret it? I have to calculate the physical distance and apply brakes, automated brakes, to do that. So all these sensors, so basically all this data is fed into central processing unit internally on the car, and there's something called as data fusion, through which they weigh out different factors, like what could be going on. And so to give an perspective from engineering perspective, right, you need to be able to capture frames in real time at a fast speed. You need to process them, right? So there is image processing involved. Then how do then there are algorithms, right? You have to write algorithms as to how you can do it more efficiently on the car, right? So that they do not consume too much processing power. Otherwise, if the system is stuck, right, just like we see the hang on our laptops or phones, like, it is very critical, right? We cannot do it, we cannot get stuck. So those are all the critical things that we need to comply with. and it is very critical to kind of do that. So all those things come as a part of the ADAS systems. Yeah, and yeah, so you might have seen in Tesla, right? They have been doing it for a long time, but the problem is it is their all internal technology, right? I mean, that is OEM, that is Tesla specific, but other third party vendors, like just I said, right, all the tier one suppliers, they also try to kind of provide an assistance so that you can integrate it as a part of any car. So it has to be a generic solution that fits in all the cars that you know that are asking for that particular solution. So based on the height of the car, the length of the car, you have to do all these calculations separately, and you have to customize these for a particular vehicle. Yeah. So this I mean, the algorithms part and all, though in India we do not have many of the cars which are used, but for the American and European parts, there are a lot of kind of I should say a lot of OEMs who are working on these, and they are going layer level 3, 4, and 5, and actively work is going on for this autonomous driving. Next slide, please. Akshat? Yeah, okay. Digital twin. Now, what is digital twin? So this is upcoming, stuff. So what is a digital twin? Okay, so in car, I know I can measure everything, right? What is my fuel level? Okay, so it's like an avatar, right? Whatever data parameters I have for me, I'll send it to the cloud. So whatever is my current geolocation, right? Let's say I am on I am near Gandhi Hall and I'm going towards east, and my fuel level is XYZ. I have 10 liters of petrol left, and currently I am playing XYZ song on my head unit, and the car temperature I have set to, let's say, 25 degrees. So all that data that you have exactly, that you see on the car, perceive on the car, an exact replica copy of the same is sent to the cloud, right? That is called as a digital twin. This could apply to anything, not just cars in general. This is a common concept that you have a digital twin of your room. Okay, you can have a digital twin of your office space. You can have a digital twin of your study room, anything of your classroom, right? So that is what digital exact parameters. If I give it to you, you know the exact condition where I am right now and how it is, right? So now the question is, how is it useful? Okay, the way it is useful is you can learn the patterns of the driver. You can collect the data on that, right? So for example, let's say if my car broke down all of a sudden, right? And if I call, let's say I call customer care, like I am stuck but I don't know what is my location, right? And if the digital twin had my last information, then the person who is trying to help me, they'll have all the information. Okay, then reach out to me because they know the last coordinates. So it's like a black box, you see, right? If you are aware of the concept black box, right? In aeroplanes they have black box which records everything that goes on, right? So this is kind of a digital real-time thing. Okay, so let's say if I am somewhere, like I want to say, can I get the movie tickets for the Regal Talkies from 3 to 4 p.m. today, right? And if I am in Rao, which will take me 2 hours to reach Regal, right? Then you can say that, sorry, you cannot reach within that allocated time, right? So based on your location, it will be able to answer you, right? So things like these, this is what the digital twin, and it can enhance the future your user experience a lot. You can ask some stuff like let's say if you're in an office and you want to go for a dinner, and you want to just ask like, do you think I have sufficient fuel for the dinner tonight, right? So it will get your current coordinates. It will calculate how much distance you have to travel, right? And it will get the information of the fuel level. It will calculate how much is your instantaneous average, and will say, okay, the distance is 50 kilometers, but I think that with your current fuel level you can go only 40 kilometers. So then it will tell you, it will interpret it, and it will, based on this location and coordinates, it will tell you, no, your fuel is not sufficient, you'll have to refuel, right? And at the same time, going one step further, if it knows that you always go to an HP petrol pump or Shell petrol pump, which is your preferred one, then it can recommend you, sorry, your fuel level is 40, is low, you need to refuel. There is an HP petrol pump on your way, do you want to route through it? And then if you say yes, then it will route it to through that particular station, so that you can save on time, and at the same time you are not anxious, right, whether I'm going to make it to the to my dinner at the right time, and whether the fuel will last or not. So these are the kind of things that you can do even if you're in office, right? My car is parked actually, and last known data is in the digital twin, so even I'm not there in the car, it can still answer all those things for me. So that's the beauty of digital twin. But you have to be connected to the cloud, and a lot of OEMs are actually going in this direction for creating the digital twins, and using it for real time answers. Yeah. Next slide, please. Accessibility. So this is one topic which is close to my heart. See, we all think that like every user is able to use the car equally, right? It is not. Okay. So recently in 2020, actually, so earlier colorblind people who are able to see everything fine, right, but they cannot distinguish the colors maybe. So Indian I mean RTOs, they'll not give driving license to them. Okay. And many countries it is allowed. Okay, in many countries it is allowed with certain modifications or certain conditions, but there is a huge number of people, because of minor issues, it could be a temporary disability also, right? So let's say, for example, I've got some eye infection, right, and I'm not able to see properly, or the brightness level is too low because it's too sunny or it's too dark, right? So I'm not able to see it properly. So for those things, so if those people are not able to perceive colors, then how will they even use the system, right? Because there are icons, as I told you, right? Just on any normal phone, right, there are coloring schemes. If you are not able to see that color, how will you even use the system, right? So Android, as I said, right, so we can use Android as an operating system. So Android already has some features to support this, right? So you can go to the accessibility mode, and so let's say there are three types of color blindness, right? I think red, blue, and green, these three ones. So if you switch to that mode, no, then you'll be able to, that person will be able to see properly, which, and the color theme is adjusted so that they can perceive the colors very efficiently. Okay, and it could be something, so let's say if some person who has vision problems, or some aged person is driving the car, and they are not able to see small letters, right, because the font size is fixed. So I should be able to increase the font size at runtime, right? So I can say commands like increase the font size, for example, right, and it will increase the font size so that I can see clearly like what buttons to push, and I can see the text. And same thing goes for like, so there is a mode like in Android phones also. If you want, you can try on your phones. If you enable accessibility, and if you touch a particular thing, it will read out for you. Okay, so if let's say you have an app for navigation, right, Google Maps, if you touch it, it will say Google Maps. And if there is any button on it for which you can see the text, and if you touch the text, it will read out for you. So let's say I've got some vision problem, or temporary vision problem, or I'm too old to see certain stuff. Even if I'm able to touch it, I'm able to reach to the point where I can launch that application of map, or if I want to switch music, let's say I'm sitting on the co-passenger side, but I'm not able to use the, I cannot switch the song, right? It's kind of the system is not able to help those people out. So those kind of things we can still customize go to that particular mode through voice commands. We can do that, and the good part is, usually Apple and Android both have fundamental features to support these. And with minor modifications, it should be possible to enable all those things for people who are not so fortunate to be able to see or perceive things. Even some people have like migraines, for example, right? If they too see too bright stuff, or they're too much fast animation, right, they're not able to perceive it and it gives them headaches. So I can disable the animation mode, for example, right? And I'll not feel the dizziness because of the animation. So these are the things which we can enhance as a part of our software. Yeah, next slide please. Generative AI, it's a huge topic, but I think I partially covered as a part of previous things that I was telling. So large language models, so you can integrate Chat GPT, Llama from Facebook, right? All those large language models, and get more stuff. Many OEMs like car manufacturers, they are integrating it now. So for example, uh, let's say I have a car manual, right? I want to know like how to open the petrol cap, right? Or how to open the bonnet, and you have a lever, right? So many people are new drivers, or if I want to say what does this check light mean, right? Sometimes there's a LED check light. So these all things are part of the manual. They give lot of thick books, right, for this, what, how you can do it and how to do it. But no one knows. I mean, you have to go through index and all these things. At runtime you cannot do anything about it. So Chat GPT or any of these LLM models, if you can get a PDF version of the same, upload it to the Chat GPT, and then you ask the questions, right? Like how can I open the bonnet, then it will dig into that, interpret it, and it will read out to you. You need to press this lever on the right side of your on the bottom of your seat to be able to open the bonnet. Things like these, these LLMs can support it, and you have to send the data to the cloud. You have to be connected. Those are all things, and it's a very huge topic, and a lot of companies are exploring on this part. So it is good to be knowing the basics of all these things and how these things are done. In the interest of time, I'll cut it short for now, because there's a lot of other stuff left. Let's move on to the next one. Testing and automation. So I'll just give you an example. Okay, testing, people think that people have perception that I'm in development, so I'm very proud, and others who are in testing, they're not so good and stuff like that. There is a lot of when you join companies, there is stuff like that. But trust me, like, testing is the most critical part of automotive environment, because there are so many issues you can find out in right time, right? That it can literally save lives. I'll give you an example. So there is a speed control volume feature that usually many cars give. Okay, and one such car in Germany, this is a real thing that has happened. So in autobahn, if you might have heard, in Germany, right, there is no speed limit. You can go to 300 kilometers an hour. There is no limit. So there is a software where you can keep increase. If you are riding at a high speed, because there is so much wind noise, it ups the volume level of the audio that you are playing back, of the music that you are playing back. But as you keep increasing the speed, it keeps on going up and up. Okay, and at one point of time, it got to such a high speed that it got unbearable for the driver. Okay, and that person was in panic, because it was at such a high volume level that he was not able to touch it and decrease the volume, and the system became unresponsive, and he had to stop the car on the autobahn, which is very dangerous thing, and had to shut down the car to be able to stop the audio. So you can just think of it, just a feature which was a fancy feature, how it could have affected the life of a person, right? So things like these, so these things should have been caught in testing, or maybe something went out of control, or some algorithm didn't, so someone did not test it properly, or some out of bound condition happened, right? So these things you can test, and this is one of the most exciting part, right, of automotive. You can see the latest cars, whatever car is coming, 1 year down the line or 2 years down the line, I'll have access to those cars. I'll be able to test my software or hardware inside the car. So there are multiple types of testing, as you can see, right? Emulator means whatever you are having in the car, you will emulate it as a part of a computer system and try different various combinations. Okay, or you can have only the radio on your in office and just test on that. And the third level is when you actually put it in the car and drive test. So all these things, right? Real time situations, how much if I am doing rear view camera, right now it consumes a lot of DSP, so everything else should shut down because it's consuming so much of resources. Right, so all these things are kind of very interesting, which I think to me personally they sound very interesting. And I wish I knew all these things when I was a student, and that's why I just want to like let you guys know, like, okay, these things like these exist. It's not about stuff that you're learning in your classroom. Obviously what I learned in classroom is the reason why I'm here. I know the DSP algorithms. I know the mathematics behind it. I know how that sensor is working, how I know how the PCM file is there, how I know the meaning of clipping of signal, right? The audio is going out of range, or the volume level is too low, or the DV level is too low. All those basic things, if you do know that, then you are able to kind of correlate and have a logical mind to solve all these issues. Sometimes it could be a hardware issue, but it can show in software and vice versa, right? So you need to understand the hardware parts, the software part, the third party applications, and your current situation of the head unit to be able to solve all these problems and come to conclusion. Yeah, so and like some of the cool stuff is like so you have this head unit, right, where you have these screens. So there are automatic robot arms which will touch randomly on the screen and test like what is the sequence randomly. And like in our offices we do see all those setups, right, because we'll run thousands and thousands of cycles of these just to ensure that this gorilla testing passes. And if you touch some random sequence, something out of control, or some untested use case does not come into picture, which could break the system at when you're driving and you're in a critical stage, right? So all those things come as a part of testing and automation. Next slide, please. Yeah, certification. So this is also one of the critical parts. This is the next level of testing. Okay, so let's say I am having Google Android Auto on my car, so it has to comply with the Google uh, you know Google certifications. Like as I told, right, I mean, since I'm from audio background, I'm just giving you examples of audio, but it could be anything. Like the display should be proper. If I press this, then XYZ should happen, right? I'll just give one of the interesting things I did was for Alexa certification. I'll tell you one interesting case. Okay. um, so Alexa devices also that you use at home, right? Maybe so if you just let it on for 24 hours, right, and if you are doing normal conversations at home, that it should not wake up on its own, which means that it should not have recognized the word Alexa. That is one of the certifications for car as well. Okay, so what we'll do is we'll play a 24-hour audio in the cars, okay, which is normal conversation. You might think that, okay, if the user is not saying Alexa, why will it wake up, right? But that's not the case. So we have played some audio, and someone said Lexus. Lexus is a car brand name, right? But they are not saying Alexa. It woke up. It thought that the user said Alexa. That's a false positive. We should not be doing it. Okay, so we run 24 hours audio. Some speech was there which we played on radio, and it was saying, "Let's get there." So that let's, some part it picked as Alexa, something it correlated to Alexa. So we had to run this test over and over again, and to tune so that it rejects all these false results. And they say that within 24 hours, if you play 24 hours audio, only 2 times Alexa should wake up. Only 2 times. Anything and everything you say. It's a very hard certification to pass. Right, so I'm just giving you examples. So for this you need to understand, like what could be causing the problem, what is the audio, is it too loud, is it about the word, is it my system is not going good, am I not doing enough noise cancellation. There can be so many things where you could be wrong. So things like these. At the same time, if I say Alexa and it doesn't recognize, that is also a problem, because then I miss the actual the user intended to recognize Alexa, but it didn't recognize. So that is the other penalty, that if I recognize too easily, then it's a false positive. If I do not recognize it, then it's a rejection. Both there is a constraint, so it is very tightly packed. And we had to sit in car in hours, and to be able to play this. So just to give an example, if you play audio from a laptop and automate this thing, it is not the exact same scenario, because laptop audio will have different, I should say, acoustic effect. So there has to be a mic simulator which will put on the seat, right? It simulates a human voice, which is very difficult to do. Okay, and then we'll run this test, we'll set up the audio, there'll be speakers which will generate the noise like a real car environment. So there'll be 10 speakers in the car, there is mouth simulator, then we have to connect to the internet so that it records every audio in the 24 hours, and we have to listen to whole 24 hours of audio whenever it does the false wake up. So these are the kind of things that we do kind of on a day-to-day basis. And for example, certification of Alexa, right? So this is another thing, right? So let's say I have to comply to their, like, normally just the login process that you have, right? So you have to have screen one, then you say, okay, scan this QR code, and then it will automatically log in and link to your account, stuff like that. So this we have to do on car also. It has to be exact sequence, otherwise they'll say, no, 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 your car is not certified for Amazon or Alexa usage, so we'll not let you use Alexa as a part of our system. Then all our efforts that we have done for months and years, they'll be gone, right? So certification also plays a very important role. And here, if you have the mind to pick on something, and you are a logical mind, then you'll be able to pick up very quickly. Yeah. Please go on to the next one, please. Side. Yeah. So just final few words from me. I knew. I mean, I wish when I was student, I knew all these things. So this is just for everyone. Just uh, know all these things, because these things matter in day-to-day life. Whether you are doing XYZ job, you are could be in any company. Find, and as a student, you try to find an area of expertise, and keep learning. Don't block anything. Let the brain absorb everything. Try to learn as wide as possible first, but also try to have 2 or 3 regions of interest that you would like to read about it, be a part of IEEE, be a member of that. Hear about technology, read about technology. Now there are so many, do, if you have to, online courses, learn about whatever excites you, just keep learning about those. And at the same time, don't overthink it. Don't the analysis paralysis, right? What if I do this and something happens? Just see, if you like something, then you'll make sure that you evaluate and plan for those things. And in the process, you'll mature a lot, and you'll take the risks, and you'll know how to proceed, and you'll not be afraid to take the next level of steps. Okay, and the area of interest may keep evolving, but that strategy, that how to step into it, try to learn it, and fear of failure should not be there. Even if you fail, it's okay. You can keep on learning different technologies, and it evolves over time. Few years ago, like industrial revolution, no one, people thought that it will take away their jobs, right? But it didn't. I mean, then new things came up. Now everyone is thinking, no, 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 if AI will take away our jobs, what will be the next thing? It's nothing like that. You'll always have stuff to do, as far as you are best in your field, and you'll have good career, and your job will be secure. And don't think overly too much. Take care of your health, exercise. Don't be just focused on scrolling videos. Just try to learn, focus, on stuff as well. Read books. It's not the same as going through tutorials or online resources, because it gives you focus time, and it gives you time to think over stuff, which you cannot do with just online resources. It gives you time to think and absorb, and be aware of the legalities. If you are working on something, is it infringing, like patent wise, is it legally infringing with something, or do you think there could be a legal question involved? Because sometimes we don't know about this stuff. Does not mean that if we don't know about it, we could still get stuck with some of these issues. So we have to be careful around those things, and if you think there is a question of if and but, you should rather dig into it and see whether it is the correct way to proceed or not. Be aware of financial planning from an early stage, because obviously financial wellness takes you need it to be financially aware and be able to save for yourself, for your loved ones, and to be able to support your dreams. And last but not the least, work for the cause that benefits others as well. We all can earn, and we can work for ourselves, and but we should try to take out time to help out others and others in need. And I mean that is the way to make everyone else around us and ourselves happy. Yeah, thanks for your time, and now we'll take the questions. um, Please go ahead with, yeah, sure. Mhm. How long is the break going to be? 5 minutes is okay. Then we can start at, let's say, if you want 3:35. Yeah, okay. 5 minutes is okay. We can do that. But if you can share the questions in the meantime to me, that will be great. Yeah. Okay. Yeah, yeah, sure. That will be great. Yeah. Yeah. Okay. Akshat, are you presenting the questions? Yeah, yeah, sorry, I was on mute. Sorry. Yeah, yeah, you can share as soon as you're done. Okay. Yeah. Okay. Thank you. Yeah, hello Akshat. Can you hear me? Yeah, can you send this document on my email by any chance? I can then locally have a copy. And yeah, email you can share, I think. Yeah, thank you. Hello, can you hear me, Akshat? How many questions are there total? Okay, okay. Maybe I'll just start taking them down. So these are the finally filtered ones, right? Okay. So, okay, can we start now? Hello, everyone is back? Okay, great. Okay. So on what subject is focus as to question number one? Okay, for core companies. Yeah, yeah. No, no, I can read. As far as you guys can see, right? So I'm answering question one now. Okay. Yeah, 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 yeah. I can see it. Yeah, yeah. Okay, okay, great then. Yeah. So I'll say whatever subjects, right? I mean, I think GSITS we have good balance of courses. So I think there is nothing specific that you can focus on. See, when I was a student, I used to think that DSP it's all theoretical and it is too much math and all for me. But as a part of job, I think it is too much relevant. If I am in that field, right now, the relevance for me is a lot, right? So it at least during our time there was not much choice of subjects to select from, but now I think curriculum has changed slightly as far as I understood, and you can have electives. But I'll say go along with the subjects that you think you like. Sometimes maybe DSP I would have not thought that it will take me to audio domain as such, right? But now I enjoy it a lot, and the fundamentals I'm able to do. So sometimes we may not like the subject, but is one of the core things that we should still learn so that we can build upon it, right? If you want to go in acoustics, for example, right, mathematics and acoustics will play a huge role. Okay, at the same time, when we are commercializing the products, let's say we have a product, the JBL line of series, right? So if it is too costly for anyone, right? So I'm coming from a point like where the economics also comes into picture, right? So you have to make sure that you minimize the cost and stuff like that, and you understand the cost related with those things as well, right? So at that point of time, I remember there was a subject where we used to be taught economics. So that time it didn't feel relevant, but now I feel it is relevant, because for engineering to be able to deliver at the right time, and with the right cost makes a huge difference. So I'll say don't think over too much. If you like some particular domain, you align your subjects with that particular line of expertise that you want to go to. Maybe some of you want to go along the software field, others may want to go for instrumentation, right? So that depends on your thought process or what your interests are. If you want to go in pure instrumentation and you like to read about sensors, and then instrumentation company is the right, then you need to stick to those courses which are more based on sensors and instrumentation. But let's say if you want to go on VLSI, maybe you want to select the VSI related elective. So that is, I should say, is more person specific as such. Does AI, I'll move on to the next one. Does AI and ML is a must for the current industry? No, it is not. But I'll say that this AI and ML is the top of the cream. Like, you build any system, right? So let's think for me and as an example, right? If I don't know the fundamentals of voice recognition, if I don't know how audio is captured, if I don't know how to play back the music, if I don't know about DSP, what is the point of having AI and ML? Because I can't use it for my application. So the thing is, AI and ML you can use when you are already an expert in that field, in any field, right? So AI and ML can be used for finance also, it can be used for autonomous driving also, it can be used for banking also, right? So AI ML by itself, I think, does not hold much value until you know where to apply it and how to apply it, right? So I'll say go to the fundamentals first, and if you can learn about this on the top of the existing fundamentals, that is the way you should take it. And I'll not say it is a must for the industry. It depends on the field which you are in and what role you are in, right? So if I am doing the tuning of let's say tuner chip, I am in the tuner domain, right? For me AI ML does not make any sense, because there's nothing I can do with AI or ML based, for just tuning the frequency, there's no use. But if I am going in the user experience, for from an automotive perspective, where I can integrate a voice recognition engine to the cloud, right? At least that connectivity should be there, then it makes sense to me, right? And you can always learn on the top of. I was not born and I never did a formal course, but today I'm working on something that that uses AI and ML, and I'm reading it parallel, doing online courses and reading it. So it was not a must for me, but I learned it because I wanted to use it. So in short, it's not a must. Go based on whatever domain you are in, and how you want to take your career for that particular field. If you are able to use it, then go ahead and do it. But it's always good to know that there is a solution that you can enhance with AI or ML experience. Third, it's difficult to understand research papers at second or third year. How can we keep ourselves updated with what's new in our field? I agree, it is very difficult, but the more you read, the more you will learn to grasp through it. When I started, for me, when I read the first IEEE, I was so much bogged down. Like, it has 10 pages, which part to do and all this stuff, right? But it's a matter of practice and art. The more you read, the more you'll be able to. Now I know that, okay, I need to go to the abstract first, and then maybe the last part where the observations are, right? So this you'll develop over a period of time. The only thing is, try to read as many as possible, and it's an art. It will evolve over time to be able to read such stuff. On the other hand, the simplified stuff for that is what you'll get as a part of this IEEE magazines, right? I remember IEEE Spectrum used to be there, right? And these kind of articles will give you a little bit insight into it, right? And at least it will, I will tell, like, it will arouse your interest in that particular subject. So start off with simpler magazines, and then I'll say read about things, let's say AI and ML if you want to read, right? Then you search for I should say core research papers, right? For each field there are some core papers which were written few years ago, on which things are built, and which are referenced in every or most of the papers. So go through those first, because they'll be the groundbreaking ones. Will they introduce all these fundamental challenges and the history behind it, built from top of that. Then keep coming to the latest ones and greatest ones, where it will narrow down to a particular uh, I should say improvement or unique identification or USP of that particular research idea. Next one, how can a fresher prepare your skill set to get in the current recession scenario? There is no recession. It's a mental thing. We are short of people. So I don't think it has to do with, and if you are the right skill person and if you have the enthusiasm and if you are working hard, there's nothing called recession. I have been in 2000 recession, middle of 2007 recession, and I was recruited by Garmin. So I think this is some excuse that we are giving ourselves. There's no recession. What advice would you give to students looking to pursue career in digital signal processing and image processing based on your experience? Okay, so I'll say go through the fundamental books that are part of your the curriculum, and don't restrict yourself to whatever is being asked in the exams. Okay, many times I remember I just read chapters which were not even a part of the curriculum, but just because they were interesting. And one there is a book called as audio and speech signal processing. Maybe if you can find that in the library. I mean, these are not core curriculum books, but that one book I specifically remember that when I read that book, it rang the bells to me. Like, wow, this is cool. Like, I can compress the audio and phone it. I can compress 16,000 bytes of data into just 200 bytes of data, and then uncompress it, and then so I'll say read books which are fundamental and are more application oriented, right? Because digital signal processing, if you think it all throws mathematics to you. But if you read, let's say, audio signal processing or image signal processing specific book, or you can also start little by little, try to use MATLAB. And let's say if you know about FFT, right, go and see what does FFT do. Okay, send an image, FFT transpose, or do all those experiments, wavelet transform on that image, get a just keep experimenting. That will give you an interest. Okay, I want this audio to sound like Obama sound. What can I do? You think on your own, and then I can transform this, or do this so that it sounds like that person's voice. So theoretically read it and try to correlate it with the tools. That's what I'll say. There is no specific book. Try to be more hands on, do experimentation. That's my advice. Okay, next, what we study is all very basic, and what company is looking doing is not what we study. I'll not say this is completely true, because sooner or later it is useful. The way you should use it, see, if you go for an interview, there are definitely a lot of things, right? We are looking for people who not only solve the technical problems, but they know how to solve the problem. It's not necessarily, I mean, I remember from my Infosys interview, we were not asked technical questions at all. We were asked puzzles and mathematical problems and whatnot. See, eventually, as an engineer, you should be able to solve problems. That needs an analytical mind. And it definitely, what courses you have done helps it. But if you want to balance the gap, do reading on your own. And nowadays, I mean, as I said, right, read books, work with tools. Now our lab is equipped. I talked to Khatri sir, and now there are so many tools that that were not available to us as such. Especially all these mathematical and I think VLSI tools are there, and MATLAB is there. So just experiment with those, and you try to experiment with them and add it as a part of resume that I did this project. A project will weigh in a lot more if you have done something that you liked and you identified all the issues and you solved them. That is what everyone is looking for. Okay, definitely it is built on the core fundamentals. If I want to have some audio effect, I cannot do it if I don't know the theoretical reason behind it. I cannot just experiment blindly and just out of a sudden some random function will give me the uh, you know expected output, right? So if I need to blur an image, I need to know what is the blurring, how which DSP algorithms blurs the image. or how does it marks the boundary of an image? What transform should I use? So it goes from theory to practical, and then your willingness to solve the problem. Yeah, so please go ahead and experiment and read. Yeah. 7, what motivates you to continuously improve and in term, especially when faced with complex? Yeah, I think it is the challenge that you see um, in the problem, and do you like solving problems? Personally, I do like solving problems, and in my peer group, I think that is what has, I'll say, set me apart. Stop complaining. If you see a problem, don't blame it on others. Just try to solve the problem, and take it as a challenge. Given that I think that I know all the stuff, can I solve this problem? If you don't know, then learn it, right? And it also like the feeling that you get when you solve that problem. Like for example, we are saying that false positives in the certification, something. So the reason to try to find out why it was causing, and then solving it when no one is able to, that gives a lot of satisfaction. That is one thing. And the second thing is, today I can say, like the software that I've written, it is being used by, in literally thousands of vehicles. Literally thousands of vehicles are using, and it is the reason that it is a boasting rights to say that, okay, I worked on this thing. And I feel proud when I say that I worked on this particular car, and the user experience, this is the part that I worked, right? So that also motivates me. And I wanted to kind of also bring in the technology to India. So I did my masters. I learned a lot of things, but I'll say over the period of years, no, all those projects that were earlier run from US or European countries, they are all moving to India. You'll be surprised. The core expertise is moving to India. The reason being, India has got a lot of talent, and we can do it. And we are very thoughtful people, and we are able to see do it with the way we are born and brought up, right? We are able to do it with minimal resources. So that pride of being able to do in India better than what others are able to do at a higher cost, this is also one motivating factor. So I think this answered your question. And next, what technical skills do you believe are essential to move forward in speech or speech systems and GPS navigation apps? I'll say mathematics, DSP. Okay, and for navigation, also try to see what different apps people are using. There is interesting called app called as What Three Words, which is completely doing, you don't need to remember geo coordinates which are high decimal values. You can just use three words like apple oranges navigate, or apple oranges radio, and it will take you to a specific geographic location with high resolution 3 by 3 meter. So you keep reading about this upcoming technologies, how people are solving problems. And yeah, definitely DSP. And if you want to go very advanced, then I'll recommend you go for masters. It could be MTech or MS, and it will help you a lot. Navigation is evolving, so that definitely needs a little bit of mathematical background, and image processing as well. So those things maybe you want to stick to. Next, what challenges a fresher candidate might face in any company? How does he or she handle those situations? I think this is what, again, a little bit overthinking. We should not think. We see a lot of challenges, and it's nothing that anyone is not able to overcome. Mostly, you need to have an open mind, right? You cannot think that I'll work only on this stuff. Initial years of any career are to explore what all I can do and what I want to do 5 or 6 years down the line. So use that time to learn as much as possible from your peers, from your other friends, other college friends who have gone in different ones. And definitely communication challenges are there. So try to interact with people, mix with people, working with different sets of people across different time zones. Maybe you have a client who is in Germany or US or Japan, China, you never know, right? So you have to go with an open mind with for other cultures. Like most of us are mostly born and brought up in MP. But we have to go with an open mind, whether it is someone from southern India, or eastern part of India, or western part of India. So that cultural things also you need to absorb as a fresher, because it's the first time exposure, and you need to respect everyone's uniqueness, right? Because going across along the years in your career, you'll have to work with everyone irrespective of their background and their education level. And you have to be humble, and be able to you may be the smartest person, but if you don't get along with people, then you might face challenge there as well. So I'll say, just this cultural thing is one of the biggest challenges that you need to overcome. To mother can't recognize English slangs and cut it out means stop it. Yeah, natural language understanding can do it. You have to train it like that. And most of the newer engines, that's where the customization is going on nowadays, right? You can have something which is related to medical field. So if you train the LLM for medical data, then it will recognize all medical related terms. If you train it for car environment, then it will recognize those. Similarly, if you train the data that you are using, if it has slangs, then it will recognize those things as well. Next question: if I start to prepare from scratch, what roadmap should I follow in instrumentation? And this question is not clear to me. Prepare from scratch. If you can get clarity on this one, I can come back to the 11th one. In the meantime, 12th: how do we prepare ourselves and build connections if we want to approach a core industry as a BTech, as they prefer to take MTech students? Okay, I'll say at least go to some field which is correlated. Okay, see, because let's say, even if for my company, I'll say it it hardly hires freshers, hardly. They always take laterals who are 2 or 3 years down the line, right? If you see my career, first 2 years I was working with Infosys on a completely random technology. Okay, so but anyways, I used those connections, I learned whatever best I could. And then when I jumped, then I understood things, and I was able to adapt to the signal processing, which was my first interest. You are right that they prefer MTech students, but as a fresher also, you can choose fields, you can be specific. I mean, if you are BTech and if you just randomly go to civil, then you cannot think of switching to, I'll say, DSP. But at least if you are towards the embedded field, let's say if you are working on C++ code, and if you want to go to automotive, for example, right, these are correlated fields, because as a part of our thing, we are writing code in Java or C or C++. So at least there should be some overlap, right? So try to learn. Let's say if you want to go into particular industry, see the job requirements for that job, see what they are looking for, and your first job you try to align with those requirements, so that you can in long term align with those. 13, there any plans to introduce driverless car technology in India? If yes, what will be the post or job opportunities in it? I think Tesla is coming for it. In India, they are opening. There will be sure some part of it. I don't know how much it will be successful, but definitely you want to go for ADAS related jobs. I have mentioned earlier in my presentation, and the technologies, I'll say, you need to know about sensors, data fusion, and the technical jobs. You can search for ADAS keyword or driverless technology, right? You will find many openings in many tier 1 companies that you saw, right? Either it will be directly with the OEMs that I listed in the presentation, or the tier 2 companies like Bosch, Harman, Visteon. So these things will have the next level of job opportunities. So you see what technologies, mostly it is embedded side, because it is signal processing real time. So you need to align with that. And there'll be kind of engineering jobs mostly, I think. Maybe a slightly different engineering, it could be like some I will say image processing related mostly, and data fusion. So that could be some computer science related opening as well, right? Because data fusion is all through software, where we evaluate all these things, right? So something along a mix and match of those two. Today, as things are getting automated, instead of physical buttons, we use commands. If I'm interested in core, how much knowledge of coding should I have? Uh, Core means I'm guessing core instrumentation technology. Code of knowledge of code definitely helps in instrumentation. Also, I think it's all embedded systems. So C++ definitely helps. There are more upcoming languages, but I think C and C++ still give the optimal results. I mean, we are still using C++ and C in our advanced technology. So I'll say stick to those because they give both low footprint and at the same time scalability of design, especially the object oriented ones, right, like C++ and Java. So I'll still say there's three languages: C++ and Java you should stick to. What are the job domains for a fresh and the requirement of company? So this is very generic, right? I mean, there are entry level jobs you can check, and the requirement for a company to hire them. So not every company like hire freshers. So you, as I said earlier, right, you should try to focus on your long term goal and the companies which are related to them, or at least technology that they're using. You should choose them so that you are not way far from where you intend to be. The various departments you talked about undergoing different types of work. So do those types of research work or possibly they are not research work. So there is two types of work, right? Where one is fundamental research kind of stuff that you do as a part of let's say master's program. Also within our company, for example, let's say there will be pure R&D department as well, and one will be application department, right? So first and foremost in any job, right, let's say we want to focus on what is at hand, right? Let's say we, an R&D works goes on the top of that, unless it's a separate R&D division as such, right, where the company is funding heavily for that. And I'll frankly tell you, the research related work, pure research work, is very limited. Research work which is related to an application where we want to solve a problem, that is more relevant or more readily available. So for example, for me, right, I cannot go in pure R&D and D and say that no, I want to work on large language model, so please give me 5 people who will work on this. It's very rare. We need to be able to cater and bring in the technology slowly, right? Okay, this is the problem that we are facing today, and I think that this can be a problem. Let's experiment, right? So there'll be a proof of concept, POC, or what we call as MVP, minimal viable products, where we'll see that we'll experiment little bit on the top of our day-to-day job, and you have to slightly stretch out a little bit and read on your own and do that. And once even when the department or even our companies try to shell in money, they'll see that there is a promising outcome from this, then only you'll get to do that work. Otherwise it is very difficult. We'll have to go to some third party and who is the expert in that field and then get those things. So for example, for us, we can get third party voice recognition engine from a company called as, let's say, Serence, right, or uh, uh, um, Nuance, right? They develop recognition engines. So I am not fundamentally doing research on recognition engine, if it is neural network based recognition engine, or is it some other technology, AI, machine language based learning that they are doing in their engine. That is what the third party is doing. I'm only integrating it, right? So that kind of distinction. So if you go to a company who is purely working on recognition technology, then you'll get more work of it. But if you're using as an application in your company like we do, then you'll only get to hear only part of it. I hope that answers the question. So I think we are done with the question. So any other questions? I would, if the faculty is also, yeah. Yeah, I can hear you. Yeah, sure. Yeah, I think the video is tilted. If you can fix it, I think. Yeah, you can stop presenting, I guess. So that, yeah, hello, sir. Yeah, good evening, sir. Yeah. Right, right. Mhm, mhm, mhm. No, no, I can see that in the questions, like many are directed at, but I think I think that's where I think, like when I was there doing I mean my undergraduation also, right? I think like all those things if you do well, right, from your end, like if you are good at whatever you're doing, if you're doing coursework throughout, and I remember like we used to do a lot of these math puzzles and all these things in parallel also, right? I mean, we also had to go through all these campus interviews and all, right? So it's not like we did something extra, extra as in like just even the preparation for exams, like if you're doing for GRE or CAT or anything, no, whatever that logical reasoning and all those things that help us, because in the end it has to be logical reasoning and logical analysis of the issues as well. But from internship perspective, I'll say, as I said, right, first try to find out your field of expertise, or interest. That is the first thing, and then you can try to narrow down on what fields that interest you, where you will not get bored, right? If you get an internship at a hospital for some department, it does not make sense, right? It's better to do something that you find relevant, even if it is for a shorter duration, right? But if it helps you, maybe if you are targeting something that uh, that is not available, in a high tech field, like some fields have high thresholds, right? For example, signal processing, I don't think will get any internship anywhere, right? Even the interns sometimes that we get, they don't get to work exactly on, because with internship time is very small or short, right? So whatever field that we get in our companies, it takes at least 1 to 2 years to get used to the whole process, and gain a good understanding of it. So internship period we should possibly use to explore the width that we see in industry, I think, rather than going for expertise in this. So let's say if I go to a manufacturing company, we can see like, okay, these are the different departments. Okay, this is one technology that we are working on. Maybe I want to work on this. Maybe I want to work on something which is related to logistics, and I can develop an algorithm for that. Maybe I can do something for quality or testing. So you should try to figure out those things, and definitely I mean, you can now online resources are there, so you can learn on your own, on the top of whatever coursework is there as a part of the college curriculum. And like you can mention those, or if you have done any projects that you internally do, because that shows an enthusiasm that you want to work on it. And I think that is what attracts most of the recruiters as such, that you have done something on your own that you like, that you can explain. If I sit and ask you questions, you can explain for hours, and you'll not stop answering, something like that. That enthusiasm should be there. So I'll say, whatever field you like, you try to figure it out, you read about it, you talk to other people about it, connect with people on LinkedIn, connect with people, try to dig people who are in the field that you want to, what are those companies doing, and try to build your expertise around that. No, no, more than happy, sir. Yeah. Mhm, 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 mhm. Yeah, so yeah, I mean, I'm not a part of the recruiting cell as such, because that is mostly driven from Bangalore, and I'm in Pune location. And second thing is, for this, I mean, they have, for the fresher level, they have a very shortlisted group of colleges actually, which are around Bangalore and Pune, right? So they don't because they have to go physically and recruit from those places, right? And our recruiting number is not like Infosys or TCS where we'll go and from every college we pick only like two, three, or five, something like that. So I think cost obviously issues are there, right? Where we have to go to other states and recruit. So that is definitely might be one concern. But yeah, I think as a part of that SAE or something, right? I think Harman is already a sponsor indirectly for this. I think that some car this thing is there, right? Car competitions are there where students design the cars and compete. So direct indirectly also, right, as I said, right, even in my team we don't hire freshers as such, right? Because we need to know that we don't want to go and teach someone like this is how you code in C++, right? We assume that and you have to solve this problem, right? Because Mhm, mhm. Right, right. Yes, yes, yes. Because these are very, yeah, yeah, these are very niche technology, right? So we cannot hire someone whom we have to teach. And sometimes what happens is many people just switch, and or they go for masters after that, right? So then all the efforts that we have put in training that person, we kind of lose all that efforts. So that is why we want to pick people who are passionate about what we are doing, what they are doing, and whom we think that they know at least basics. No one knows everything, right? We can always train little bit and then they can do it on their own. That's And especially being a product company, it's very different from service companies, right? Like software companies where you randomly allocate a technology. It does not happen like that. You are chosen for a particular goal. Mhm, mhm. Sure, sure. Yeah. Right, 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 right. Yeah, sure. More than happy to help, sir. Yeah, definitely. Yeah. Okay then. Okay then. Thank you, everyone. Thanks for your time. Yeah. Thank you. Okay, I'll drop the call now. Thank you.